Push that rock with Simpson math. Let's integrate this product of trigonometric functions. And we'll see this odd man. And you might want to do odd man out, but hold your horses. Don't get too carried away with that nice trick I showed you in the previous video. Here, what if I let tangent of x be u? Then du, the derivative of tangent, the differential of u would be the derivative of tangent, which is secant squared x dx. And that's exactly what we have over here. So we can just directly use u sub. U sub in u for tangent, and it's going to work beautifully. So I put in u for tangent, I have u to the 7th, and then this secant squared dx is just du. So now I'm just integrating u to the 7th, which is u to the 8th with a coefficient of 1/8 out front using the power rule. And so the final answer is 1/8 tangent to, when I resubstitute, remember u was tan. So tangent to the 8th power plus c, baby. So, don't get too all giddy with the odd man out rule. But other times the odd man out rule is going to help. Here it's going to help. What I'm going to do is I'm going to put an odd man. How do I know? Well, I try. On this one, I might have tried odd man out and it might have got really scary. Here, I might not try odd man out and it doesn't work. So you just try things. Okay, but I can see here that if I put an odd man out, if I put out a tangent, and I also put out a secant, so that I have a secant x tangent x dx. Well, that's the derivative of something. In fact, it's the derivative of secant. So I'm going to let u be secant, so that du is secant x tangent x dx. Now that means I can put in u for this secant, and I can put in du for this secant x tangent x. So secant x tangent x dx is going to be my du, okay? And then my secant here is going to be my u. But what about this? Oh, that's okay. We have the Pythagorean. We know that tangent, let's see, let's write that as tangent squared 3 times. Tangent squared x times tangent squared x times tangent squared x. And then we have all that. Oh, I'm not going to be able to squeeze it in. Secant squared x, blah, 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 blah. Okay. So wait, a tangent squared is equal to secant squared minus 1. So every one of those tangent squareds is a secant squared x minus 1. And I have 3 of them. So that's to the 3rd power. And then I have this secant squared here. Okay. And then I have my secant x tangent x dx. Is that tangent legible? You say, why are you worrying about legibility? You never do. Okay, so I changed tangent to the 6th to tan squared, tan squared, tan squared, but I realized every one of those tan squareds is sec squared x minus 1. And I have 3 of those, and so I have sec squared x minus 1 to the 3rd power. How about that? Let's do our u sub now. So everywhere I have a sec, I put a u. So I have u squared minus 1, and it's being cubed. Then I have a u squared here. And then everywhere I have a sec x tan x dx, I put a du. Oh, so we're just integrating this. Now, naturally, this is a pretty complicated deal here. We have to be able to cube. So, if you remember your Pascal's triangle, so we have to raise this to the 3rd power and get to the 6th power. Then we have to raise it to the 2nd power, but multiply it by this guy to the 1st power. So we're going to get minus u to this to the 2nd power would be u to the 4th, and then multiply it by 3. Or you can sit here and just FOIL this out 3 times if you like. And then I have to make this to the 1st power. So there was the 3rd power, the 2nd power, the 1st power. So u squared times this to the 2nd power. So plus and another 3u squared. And then I need this to the 0 power and this to the 3rd power, so I get minus 1. Whew, boy, that was kind of tough to keep straight in my head, all the signs. Now I'm going to distribute the u squared, and so I get u to the 8th minus 3u to the 6th plus 3u to the 4th minus u squared, but not distribute the du. And now I need some scratch paper. So to finish this problem off, so I'm going to just use power rule. So that'll be u to the 9th with a 1/9 out front minus u to the 7th with a 3/7 out front because it's 1/7 times 3 plus, let's see, that's going to be 3/5 u to the 5th because you add 1 to the power, you get 5, and 1/5 times 3 is 3/5 minus 1/3 u to the 3. And then you resub. That's all of those are secants. So I have 1/9 sec to the 9th x minus 3/7 sec to the 7th x plus 3/5 sec to the 5th x minus 1/3 sec to the 3rd x plus c by b. Math made simple. Simpson Math.